If matrix A is a 12 by 9 matrix, what is the largest possible rank? What about if matrix A is a 9 by 12 matrix? What is the largest rank then? And explain. So what is the rank? So let's just quickly remind ourselves. The rank of a matrix A is equal to the dimension of the column space of matrix A, which is equal to the number of pivot columns. So we are being asked here for these two different cases, what is the largest number of pivot columns that matrix can have? So part one, we're going to suppose that A is an M by N matrix defined as 12 by 9. And so we know that this matrix has 12 rows and 9 columns. So while there are 12 rows, there are only 9 columns in this matrix. So we can note that since A has N equals 9 columns, it can have at most 9 pivot columns. And assuming that each one of these pivot columns, each one of these 9 columns is a pivot column, then therefore the largest possible rank of matrix A, where A is a 12 by 9 matrix, is equal to 9. Because we know that the pivot columns form a basis for the column space. And since the dimension of our column space is the number of pivots, the largest possible rank of this matrix is 9. So similarly, let's now reverse the size. Let's think about the transpose of this case. So we want to now suppose A is an M by N matrix such that we have such that it has a size 9 by 12. So what is this telling us? This tells us that this matrix has 9 rows and 12 columns. So we want to be a little careful here, but we're going to use the same logic. So we know that matrix A has 12 columns, but it only has 9 rows. So what does this tell us? This tells us that matrix A can have at most 9 pivot positions. So A can have at most 9 pivot positions. So therefore, the largest number of pivot columns, or the largest possible rank, is only 9 here. So the largest possible rank of this matrix is, again, 9. And this is our beautiful final answer.